are formulas that we learned in the class before the break. So you need, this is what I have put on the screen is the formula sheet. These are stuff we learned before the Easter break. So you need to use these formulas to do question 1 on the tutorial sheet. Alright? You don't need to copy this because these are already in your lecture notes. Should be in your notes somewhere.
I did like
Anybody wants to give in their coursework, art coursework? You can do some okay. Oh, you guys, you already done? These are formulas that we talked about before the Easter break. So you need to use these formulas to do all the questions on the sheet number on the tutorial sheet, right? So can you guys do the first question, please? Question 1. Straightforward, guys. Make sure you sign the attendance sheet. Yeah, come on. You pick. Anybody wants to hand in art coursework? The art coursework. Anybody else? Thank you. Anyone else? No. You guys done question 1, please? Can you done question 1?
I'm expecting big numbers really this semester. There's pressure on you now. At least 95%.
I mean, you just need to simply apply the rules. These are the formulas formulas you need to apply. Okay. So let me show you how to do question 1. Okay. So using this.
I'm pretty sure I started it, but I didn't get full.
Alright, can you listen, guys? So in question 1 you have part 1, you're testing you're testing this versus this, okay? And the standard deviation is given as sigma equal to 30, and n is given as 40, right? So the question is determine the rejection region in this case. So what do you think the rejection region would be? I mean, it's simply here, right? This is the formula sheet I showed you a minute ago. So the rejection, so reject H0 if root of n divided by sigma times x bar. X bar is I'll figure out what that is in a sec. This is the rejection rule that you need to use, right? Now this is the same as your n is 40, so square root of 40 divided by sigma is 30. X bar is your x bar is x bar is what? Is just x bar. Mu 0 is 200. Greater than little z 1 minus alpha by 2. Alpha, if you take alpha to be 0.05, this will be 1 minus 0.025, right? And this is the same as now can somebody read this for me? What is z of point? This is 0.975. Can somebody read this off the table? There's a table in front of you guys.
1.96.
1.96. So the answer is 1.96. So this is the answer to part 1 when alpha is 0.05. Okay, if okay. Hello. Do you guys follow this or not? Yes. Any questions? Now, if alpha is 0.01, if alpha is 0.01, right, then you will have root of 40 divided by 30 x bar minus 200 divided by z 1 minus 0.01 divided by 2, right, which is okay. Now this is gonna be z 0.005, so it's gonna be 0.995. Can somebody read this 0.995 off the table? Hello.
3.3.
2 point?
3.3.
3.3. So it's 3.3. So the rejection rule, if in the case alpha is 0.01, would be okay. So that's question 1, guys. Now can you do question 2? Part 2 is similar, so can you move on to question 2, please? Question 2. Alright, we just finished question 1. Can you? The other parts are similar, so I'm not going to do that. Question 2, please. I'll put the. You don't need to copy this down. Okay, this is the formula sheet. Oh, you want to copy it down? You done? Okay. This is the formula sheet we need to use. All right, guys. Can you do? Can you move on to question 2, please? You use the same. How do you? Oh, you. I sent you 100 emails, but you never answered my emails. Yeah. Have you done the UNQ? Because I think you haven't done it. Yeah. Check your emails. Good. You haven't done it. The link for that is, you look at 15, I don't know what this the 15th of April, check 15th of April. No, not from me, from the university. Not from the university. Just check for me. Anyway, you need something before I will remove the marks. Just try to complete before the guys, anybody else wants to handle the art course? No,
we don't have a note.
Art course.
Oh, the sheet. Oh, yeah. Yeah, you sent us a sheet. Well, I have it in my bag to
Just one page. Okay, thank you. Can you guys do question 2, please? Question 2.
Yeah, it's only on when it's nine. So it's the first column. That's good. You guys sign. You guys sign. You done question 2, guys? Alright, this is question 1. Next one, question 2. Alright, let's see how we can do question 2, okay? So you have here testing for so alpha is 0.05 and your n is 10 and your sigma squared is 3. So what's the rejection rule in this case? I just showed you a second ago. The rejection rule, if you reject H0, if root of n, which is root of 10, divided by sigma, which is root of 3, times x bar minus 0 is greater than z 1 minus alpha, which is 0.95. Right? Do you guys follow me or not? Do you see how I got this formula? It's just from the formula sheet. It's from this formula sheet, guys. Right? Yeah? Now, can somebody tell me what this is? Hello? What is that 0.95? Can you read the table, please?
1.645.
1.645. Okay?
So this is part 1. Okay, part 2. Are you guys okay with this or not? Hello guys. Do you follow this? Yeah? Alright, part 2 is to calculate the probability of type 2 error if the true value of mu is equal to 1. Alright? So we want, remember, the probability of type 2 error. I talked about this before the Easter break, you may remember. I know it's too long ago. It's the probability of accepting the null hypothesis when h1 is true, which is, in this case, we are taking mu to be equal to 1. Right? So this is the probability that yeah. Okay, guys. Right, now this is where, because the true population mean now is 1 and it's not 0, this is where you need to do the following trick. You need to, you will need to do this. Right? The reason I'm doing this will become clear in a minute. I'm going to take the second one to the right hand side, so this will become now. You should look at this. You should look at this guy here, right? Condition on mu equal to 1. This has what distribution? Do you guys recall? Condition on mu equal to 1. This thing here will have you forgot the what? I think you had too long of a break. Come on guys, don't you remember that if you have, you know, this property that if x1 to xn are IID normal with parameters mu and sigma squared, then x bar, the average or the sample mean, has the normal distribution with these parameters. Alright, so this is the property I'm referring to. Then this is one of the properties you need to remember for the exam, I think. Right? Do you remember this property that if you have IID random sample from a normal, then x bar has this. So now, because the true population mean now is equal to 1, right? X bar became, because of this fact here, right? What you have here is the standard normal variable less than or equal to 1.645. Okay. All right. Do you follow what I'm saying? This because using this fact, right? You can say that after standardization, right? Or in other words, maybe I should write it here. This implies that root of n divided by sigma times x bar minus mu follows the standard normal distribution. Right? And this is what I have used here. Right? That this property, that root of n by sigma times this is standard normal. So what you have is phi, capital Phi is the CDF, standard normal. Okay. Alright, so that's part 2, guys. Are you okay with this or not? So this is the answer to part 2. Now part 3. Well, just ignore part 3. Can you move on to question 3, please? Now, question 3. We'll get back to part 3 later for a different. Can you move on to the next question, please? Yes.
In the example, we need the answer to that.
Yeah, you can do the last thing. Yeah.
So part 3. Okay. Before in here, you said that set 0.95 was.
Yeah, 95 is look, 95 is halfway between these two.
Oh,
Yeah, can you see this? Let me show you. Between halfway, it's halfway between these two, right? So it's 1.645. That's like the depth.
Okay.
Next question. Yeah. No. And you should look for 0.95, sir. There's 0.95. There's no exact 0.95 there. It's this number and this number. So it's halfway between these two. So that's how you've got 1.64 and 1.65. So the halfway point between 1.6 and 4.5. So you see, I got it, that's 1.645. It's halfway between these two.
So that's 1.645.
Yeah.
If it were this number, it would be 1.945.
So if it is, if it's halfway between these two, then it would be 1.945. Yeah.
I am going to use yeah, because I'm sure we can work it out.
You don't follow? Because you
said there's something
right.
then you just times it by 250 and that I'm sure they give you that. Right? No, this is the property right now. So basically, because he took a sample, yeah, and that sample obviously it is variance, but so just divided by which will give us the normal variance. Because you need the whole population. So yeah, you
formula shape here.
Yeah. Okay, The formula sheet is back on, guys. So to do question 3, can you use this, please?
Oh wait.
You guys okay? Your eyes up.
This question, I'll be able to use t solution. So n is choose one.
Yeah, so you just need to approximate. So you just so basically closest you can get is 100.
Okay.
Yeah, so you just choose the one for 100. Yeah. Hello, ma'am. You okay? Anybody wants to hand in their coursework? Coursework. Good. Thank you. You come on.
Yes, thank you.
Can you make sure you sign your attendance sheet, guys? The attendance sheet going around somewhere.
Next time. Sammy, let's talk next time. Okay.
Yeah.
I'll bet it's pretty fast. Is it now or not?
You're doing question 3. All right, guys. Shh. Let me show you how to do question 3 if you haven't done it.
Yes, that would be very more stress-free day than my last stress. No, she works for. She works in Singapore. Yeah, just
Yeah, he used to go to our school. He was super clever.
That's nice. Now I just banter.
All right. Could you listen, guys? This is question number 3. You're testing this versus this. The sample size is 250. The sample mean is this, and the sample variance is this. So we want to test. So the rule for reject. So we reject H0 if what? I just gave you, these are the rules you need to follow, okay? So, so if root of n, which is root of 250, divided by root of s, which is the root of 2484, okay, times x bar, which is minus mu 0, which is 1800, okay, is greater than t. You need to use the t table. I'm sure the t table is in front of you guys, right? The t table with n minus 1 degree of freedom, which is 249 times 1 minus alpha by 2. The alpha is, let me see, alpha is 5%. So what? It's 5%. So 1 minus alpha by 2 will be 0.975. Right. Now, if you read the table, do you see the table in front of you? Let me show you. If you read the table, guys, this is the table. Right? There's no 249 here. Right? There's no 249 in the table. So the closest you can have is 100. 100 is the closest you can get to 249. Right? So the number you're looking for is this number here, 1.984. Right? Because you're looking for 0.975, yeah, which is 1.984, right? So the answer is, so this happens if .984. Right? So this is the answer. I mean, you can work it out if you have a calculator, but I won't be bothered. So can you go to the next question, please? Question 4, please. Can you do question 4, please, now? Yeah, that's because 1 minus alpha by 2. So alpha is 0.05. If alpha is 0.05, 1 minus alpha by 2 is 0.975. You guys guess. In this question, madam, it says we have a sample of 250 and this is the mean and this is the sample variance. So that means you don't know what the population variance is. You don't know what the population variance is. But in this case, we know what the population variance is. Population standard deviation is there. But here you don't know what, so we need to get. Yes. But here you just have a sample and this is a sample.
Yes. Since you don't want to know the sum of variance is 4. So you go back and forth. Question 4.
Yeah.
So you want to go back and forth.
Yeah, that's right. Yeah. I'll put the formulas back. Put the. All right. For question 4, you again you need these formulas. All of you sign the attendance sheet, guys. Where's the attendance sheet? You have it? You have it. Anyone else? You haven't signed. Thank you. Anyone else? Yes. All right, guys. Question 4. Question 4 is about you have okay. Question 4 is not really difficult. I mean, it's just basically. Question 4 is similar to question 1. So basically you need to use let me show you how to do question 4. You are testing okay, so you have n is 20, your sigma is 8.7, x bar is 252.96, and your alpha is 0.05. Okay, so part 1 is to find the rejection rule. All right, so we reject H0 if. So what's the rule here? I mean, if you look at the formula sheet, the rule for rejecting is root of n, which is root of 20, divided by sigma, which is 8.7, x bar, which is 252.96, minus mu 0, which is 250. Okay, it's greater than z1 minus alpha, which is z0.95, right, which is as you know, is 1.645. Alright, so you can work it out. I'm not going to work this out. I'm sure all of you have calculators. You can work this out and see whether... Hello guys, you listening now? You can work this out and see if it is greater than 1.645. Yeah? Okay, and part 2 is to calculate the probability of rejecting H0. Alright, when the true mean is 255. Okay. So in this case, you reject H0 when Alright, now to calculate this, you need to change this, because the true mean is now 255 and not 250. You need to change this to 255. So you need to change this to 255. So I'm gonna subtract the 5. Okay. So because I subtracted a 5, I need to do the same thing on the right hand side. Okay. Now, because of the argument that I used previously, right? This guy here, because of the argument I used with question 2, I remember, question 1, I think, question 2. This guy here has a standard normal distribution. Alright? So the answer to question 4 is 1 minus 5 times 1.645 minus square root of 20 multiplied by 5 divided by 8.7. Alright, so we're done with question 4. Can you do the remaining ones by yourself? And if you have any questions, you can look up the solutions online or come and see me. Right? You got the clear? Yeah. This is the same idea that I used in question number 2. You may recall. Yeah. Yeah. Thank you. Anybody who hasn't signed this?
For confidence interval, does it matter whether it's
small one equal to or just smaller one?
It doesn't matter. No.
It doesn't matter. Second to n.
Hello.
Can you check?
Oh, yeah, sure. Thank you.
I'll wait for myself to go.
Thank you. Hello, sir.
In that last question, you obviously got the shirt map, and then you have the left side greater than the right side.
Yeah.
But on question 2, it was accept HO. So you put
Yeah.
left side. Is that why? Because it's accept and reject.
Yeah.
That's why.
But the idea of working as the subtraction and adding is the same.
Because it's whatever accept and reject.
Yes.
So the very last question, we only had the first line was 252 minus 250. And take it that's 250 because that's what hypothesized u is equal to. And we can take 5 off both sides, so it's 255, which is what we know the true value is, and then we can turn it into a normal.
Yeah.
Perfect.
That's right.
Thank you.
Yeah, exactly. Yeah, sure.